CS.
Cool. Anyone else want to share? Any math CS people?
Hi.
Yeah, Isha. Cool.
I started recording this, so if you're talking, you might get recorded. So if you don't want to be recorded, I guess you can text the question to us for whatever reason.
Do you want to just start intros?
Yeah, we can start intros, and maybe Joseph will be here by then. This is currently rumors.
Ready?
So, hi, my name is David. I'm also known as Where's the Exit on the Discord. I'm a math CS major, 4th year, so this is my last quarter. I'm graduating. I'm interested generally in kind of theory of generalization of deep networks, somewhat adversarial robustness, and efficient learning in general. Yeah, I'm going to be going to the master's program at University of Toronto after this semester.
Hi everyone, I'm Jason. I'm a 4th year CS major from New York. I've done AI research, some applications, more recently going into theory, and slowly starting a PhD program too at UIUC. So if you have any questions on grad school,
I can't pick your sound up.
Oh no.
Is your video? No, the video is all just audio. I see.
Cool. All right. I'm John. I'm the director of marketing for ACMAI, and I've been in this role for 2 years now. You've probably seen me on the Discord when I ping at everyone. I'm a 2nd year transfer. My major is computer science, getting a minor in math. I've done AI research in a few areas. So right now I'm working on robotics, and my favorite robot's Baymax. So if you've ever seen me on Discord as well, that's my profile picture. Yeah, happy to have you all here, and I'll give it to Stone.
Hi, my name's Stone. He and his, Marshall College. I'm currently a 3rd year studying CogSci and computer science. My main interests are within reinforcement learning, some bits of language modeling stuff, and this intersections with robotics potentially. I'm the guy with the diamond logo and the one that has T2000 in his name on Discord. That at one point everyone copied me for some reason.
They all have T2000.
Yeah, I don't know why. Prior to that, I actually wasn't really doing as much AI research stuff. I only started really maybe end of 2nd year. Prior to that, I was doing a lot more software engineering. So I was your standard front-end dev. I did front-end for a while. That's how I got into computer science. I did a lot of front-end, and then on the side, I occasionally competed, albeit kind of horribly. And then I got really into AI and maybe start of 2nd year.
Yeah. Did you say you were our president too?
Yeah, I'm also the president.
He's president of our org and founder.
Yep.
So he's our father.
All right.
All right.
Keep going.
Yeah. So for today's topics, we're going to be covering a few things. So first off, we're going to do the motivation of why would you ever want to do AI research. Next, we're going to get into how you can get experience with AI research. All right. Yeah, could someone get the door? Thanks. Yeah, I think the meat of today is going to be about experience and also the Q&A section. For experience, we're going to talk about how we got our experience doing AI research, as well as how you can approach this. Also, where can you go with AI research? You know, there's academia and there's industry. How would one choose? And how do you know which one's a better fit? And yeah, the Q&A is a time for everyone to interact with us. This is a very casual setting, so hopefully you're encouraged to ask us whatever questions, no matter how specific they are. And yeah, I think that's the topics we'll be talking about. Any questions so far? If not, we can just get right into it. All right. So yeah, for motivation of doing AI research, we've kind of distributed this into something that hopefully you guys can interpret. So it can come from two places. The first place that it can come from is you can have direct exposure to something in your life that maybe inspires you to do AI research. So maybe a really close one got in a car accident and it got you thinking, how can I make a safer vehicle? Maybe someone was diagnosed with a disease, but maybe they ended up passing away because it wasn't a proper surgery or the diagnosis wasn't done in time. Also, that's Joseph. He's our fifth panelist. Introduce himself now.
Yeah, Joseph, you can introduce yourself.
Hi, I'm Joseph. I'm a fourth year MFCS/nano engineering major. I'll be graduating like this quarter and I'll be working at Roblox for my new grad as a software engineer.
Cool. So yeah, you can have like direct exposure to something in your life that maybe inspired you to want to dig deeper into a problem and think, how can I make a safer car? How can I diagnose diseases better? How can I do something better than what is currently available? The other thing is you can also have direct exposure later on in your life to something like programming or something in STEM, where problem solving skills are very important. And after a while, you start thinking, are there any open problems that I can solve? Are there things in this world that I think I can work on for the rest of my life that maybe could help someone out? And in that sense, that's where you end up doing research. There's a distinction between doing research and something like software engineering. I don't have experience doing software engineering, but some of our other panelists do. So maybe right now is a good time to talk about some of those differences between software engineering and also doing research, and like how you ended up doing research ultimately. So
I could talk very briefly about that. At one point, I wasn't sure if I wanted to do software engineering or research. Actually, I didn't even really know what research was, but I was curious, and so I kind of checked it out. But I did an internship in industry. I checked out software engineering for a bit, also a bit of program management. And sort of the main difference between these two areas is sort of like in research, actually in software engineering / industry, you're usually like placed in a team that's very hierarchical. And so you're kind of given these tasks. You have some freedom about how to go about doing these tasks, but really it's like always going to be aligned with the business goal or something. Versus industry, it's more about, versus research, usually it's more about like contributing to science, absent of any like financial pursuits in a business, right? So it's about like pure questions or maybe applications, just answering questions that don't really have like a clear path to answering, versus in industry or in software engineering, it's like, oh, make a website, make an app, right? Like lots of people have done that before. In industry, in research, it's like, how to say, it's like you have these problems that are really hard and there's no like clear path to solve it. And so it's like less structured. There's like more uncertainties, I think, in research.
yeah. Anyone else want to comment on that?
I can talk about a bit of my background. So like I started as a nano engineer. So I wasn't actually math CS from the beginning. So like all my research experiences and all I've done was like I was mixing chemicals, I was making polymers. And basically around the middle of my second year, like I realized that there's actually like a whole dimension to like data in like material science, and like there hasn't really been like an established way to manipulate that data. And that's sort of like how I got motivated to move into machine learning, because that was sort of my so my exploration into like figuring out like, how can I solve like this domain problem. And my angle into machine learning was from that angle. So I didn't really go to like the traditional CS angle where like, I got interested like in the concept of machine learning itself, or like, solving machine learning problems like directly. My initial interest was more of like, how do I solve my domain problem with machine learning? And it eventually like sort of as I got my hands dirty in like machine learning and like learning all these techniques, that's when I saw like develop like a greater interest of like, how do I make these methods like better, or like, and how do I adapt them to my domain? Because material science and engineering is not necessarily like, it doesn't necessarily have the same kind of structure as other kinds of data like images and stuff like that. So there's a lot of interesting problems that can be explored in that angle, and that's how I got motivated to do like AI research.
All right, thanks for sharing. Did you want to comment on anything? So,
We should actually move a little faster.
okay,
We're around time for questions.
okay. So next, let's see. I think this is actually covering the topic. Let's try to move this.
You just break out.
Okay. All right. So there's also this caveat with research, which is like, how do you get into it? And first things first, you need to find an advisor or a lab to work with. And there's many ways you can do that. First, if you are currently taking a class and you're really enjoying the material, then what you can do is be very active in office hours, engage in talking with your professor about the material, and possibly if their research looks interesting to you, then you can read some of their recent works, build up a decent understanding of what they're interested in, and see if you would like to contribute to that line of work as well. If they know who you are and you go to these like their office hours frequently, they know your face and so forth, then I'm sure in most situations they would make an exception for you to maybe join their group or to work with them. There's tons of ways you can do this. It doesn't matter the department of the course either. You could be an electrical engineering major wanting to work in a structural engineering lab, or computer science wanting to work in ECE. Really, as long as that problem that you want to work on aligns with your interests, then find ways to engage with those people. Suppose you're not taking a class with them, then what can you do? Most of us on the panel have either done one of these things on the slides that you see. So we've either done cold emails where you write a nice email with your resume attached, possibly saying, hi, I'm so-and-so. I was looking at your research on XYZ. I think it's very interesting. I'd like to contribute to it, and I have some ideas that I can bring forth that I'd like to work on. Is there any way that we could schedule a meeting, or that I could join your group to discuss this further? And I think when you go from that approach, sometimes it might not work, but I think in my case, I've sent a lot of cold emails, and I think I sent up to work with my current advisor. A lot of advisors in general are very busy people, and you can expect them to have a busy inbox. So even if you send an email, they might not get a chance to read it. That's especially the case with advisors who are highly cited. They tend to be really busy with research collaborations. And so you'll have to think of a more creative way to get their attention. But yeah, in those cold emails, the ones that I've sent, I think my current advisor, I sent like a third email. And after the third email, he got back to me. And yeah, I think it's about being persistent, and honestly, you don't want to be annoying about it. But if you do think that you have something clear in your mind that you want to work on, and also you know what you have to offer to this group, then you shouldn't second guess yourself. And I think there's a good chance that you'll end up in some research lab, especially if you already have the most important component, which is an idea and some sort of passion that is pushing you forward. You don't want to do research if you don't like it. And yeah, besides finding an advisor directly from a cold email or maybe taking a class, you can also apply to programs. Some of us on the panel, like Jason and I, did the CSE Early Research Scholars Program. That's designed for, I think, first and second year students, like students at the end of their first year and starting their second year of the computer science major. And sometimes they make exceptions for anyone outside of the CSU department to participate. And also if you're a first year transfer, you can apply. Besides that, there's also the GEAR program, which is, I think, the Guided Engineering Apprenticeship Program, something like that. And that's offered for anyone who's not in CSE, but they are in the Jacobs School. So that's another program similar to ERSP. There's the ECE SRIP program, which is offered in spring and summer, where you can work with some of the ECE faculty on a research project either during the spring quarter or during the summer. There's also the Undergraduate Research Hub, and we provided a link to the website. And on the Undergraduate Research Hub, they have tons of programs, like tons. We couldn't fit them all on this slide, but just to name a few, there's like TRELS, there's the Faculty Mentor Program, there's the McNair Research Program. I mean, there's tons of them. So definitely check out their website, and they have a lot of opportunities that you can apply to as well. It's also not guaranteed that if you apply to this program and get in, that they will match you to an advisor, but they can certainly help you in matching with someone, especially because in prior years, lots of students either come in with an advisor already, or they express interest in maybe 5 or 6 people, and you can speak with one of the program coordinators and say, hey, this is the list of the faculty I want to work with. Is there any possibility you can get me in contact with them so we can talk further? And I think that's also a strategy you can try out. That's all I have to say for this slide.
Yeah,
yeah.
I wanted to add, so two kind of things or perspectives when you're going about, let's say, for example, looking for advisors. Don't necessarily restrict yourself to like just faculty within the CS department. Even at the very least, ECE department has quite a few people that are doing ML and very like ML adjacent things. Beyond that, in many other departments, you're going to have people that are working on like some domain problem, and they're going to be using ML techniques and ML methods for them. And if you are interested in other of these domain problems, definitely seek out these people, and they'll be oftentimes more kind of interested in getting new people along, because they generally have kind of less access to machine learning, either savvy or interested students, since a lot of them happen to be like CS department and chasing after CS labs. I would also really like to kind of, at least in my experience, double down on this kind of talking with professors and classes that you're in, and even potentially just looking for like elective classes, or even not being afraid to like try like a grad seminar course in a specific subject, just to be able to get this chance to like talk with a professor, go to their office hours, ask good questions. So really think about kind of the material that you might be covering in class, and what might be kind of extensions or things that aren't covered in class, but sort of pique your curiosity or interest. And sort of like feel very kind of free and comfortable talking and asking professors directly, sending them an email. All of these things really help in terms of setting a really good impression, because most of the professors, most of the students that they teach, especially undergrads, are absolutely not interested in the material in a sense. And they don't express any interest, any enthusiasm. And out of those that even do, a lot of them might be too shy or too afraid to like talk with them during office hours or whatever. And so kind of use that knowledge as an important tool.
I also like to add that don't like don't restrict yourself to like thinking that it has to be even like like technically adjacent to machine learning, because I have a friend who literally joined my nano lab, and my nano lab doesn't do any machine learning whatsoever. And he and I managed to like work together, and we are actually now currently doing like a machine learning project within that thing, like self-initiated. And also like and it's something like you do need buy-in from the professor, but like it's sort of like it's as long as you're willing to like put in the effort and learn things yourself and find like people willing to advise you, like there's a lot you can work with And I think even in the nano department, there are professors that do like exclusively like machine learning in material science, for example, and they cover like a lot of very interesting architectures too. So like do consider like all of them, and scripts is another one, cognitive science, structural engineering, all is listed here. There's a few others. So like consider the whole spectrum, and some experience is better than like, you know, the ideal experience you want, because everyone has like a dream professor they want to work for, obviously. But sometimes what you can do is like you can work with like at least a professor, use the experience to go like, hey, I at least did X, Y, Z in this lab, something concrete, and I'm now interested in your lab. And usually that transfer works. I've seen it work. Like professors are also like, even like professors that are like usually very hard to reach are more accessible if you're like coming from that angle, like, hey, I'm actually in this lab and I would like to work with your lab on this project. And that's also another angle. So like if you want to like eventually work with some professor that you really wanted to work with in the CS department, that's also another angle.
I just want to add a very quick note, and then I think we should move on. But the point here that says like see any special instructions on the professor's website. So some professors might not be taking in any new students, and that's pretty important to know before you go commit to something like taking a hard grad course to try to impress the professor. So always check their website first. Sometimes they're outdated, sometimes they haven't updated since like the 1990s. But usually if they're like more updated, and they might have like a little section that's like, if you're interested in working with me, you know, here's what to do. Check to make sure if there's anything like that first. If there isn't, then you can try all these other methods too.
Oh, and if the professor doesn't like seem to be responding, some big professor, try reaching out to one of their PhD students, because those students are probably far less swamped in terms of emails.
Yeah, that's true. All right, next slide. All right, okay, so what can we do in AI research? I think the purpose of this slide is just to talk about us panelists, like what some of our personal experiences are. I think we can just go right to left, if that works.
Right.
Yeah, which
Yeah,
side, which
so
right?
in-
You're right.
My right to left, sorry.
Okay.
I guess within AI, there's quite a lot of domains. You have a lot of intersections as well. There's a whole ton of people doing biology and machine learning. There's a ton of people doing nano engineering and machine learning. There's a whole ton of people doing I don't know what stuff. So there's quite a lot you can do, especially because of the AI. It's fairly ubiquitous as a technology. You basically use it in everything. There's always almost some way you can apply it to some domain, and apart from the kind of applied science approaches, it's also the basic science approaches where you actually study the algorithms, or you actually study the models and architectures to improve some task. So there's a wide variety. People here have done NLP, computer vision, various other things. I can personally talk about mine at least. So within AI research, there's actually maybe two things you need to be aware when you're actually doing. So actually, there's three things. It seems like in my experience, there are professors who hire students or take on students, put them on a project, and then that's it. And then we have professors who will put you on a kind of larger project that's being led by another PhD student or himself, the professor themselves, and of which then it culminates into like a paper or some kind of poster presentation of which you are like named on there. And the third one, which is the most desirable, I think you would want to seek, is being able to start your own project, either at the guidance of your professor or something that you propose, and then have people work with you on it. I kind of see it as three categories. So for example, me last year, I joined a larger effort for a couple other PhD students, so I didn't lead it at all. And I ended up being just one of the authors, but not the first author. This year, I've moved up, and now I'm working on my own first author project, which is basically my own directions now. So just keep that in mind, because I know there are some professors who aren't very explicit about whether or not you'll be included as an important member or not. Because sometimes they don't want to tell you. I know some professors kind of are like, they don't want to give a student the bad news that maybe they don't think you're good enough or whatever. But the most important thing is you need to know your own value first. If you don't know where you are, if you're maybe not, if you don't know where you are, it's hard for you to gauge how important you are to the professor, because especially with future, if you're applying to grad school, especially, you need good recommendations. And it helps to have publications under your belt beforehand, but it's not necessary actually. So knowing what your end product is going to be like starts from knowing your own value first, starts from knowing what your professors, your advisors expectations are and what they think of you, which also leads to the second point, which is I highly recommend to talk to your professor. Like if you join the lab, you try to find opportunities to talk to them. So something that you could be a topic, like let's say I'm considering to apply to grad school, either master's or PhD. What do you think about my chances? What do you think I should be working on? Classes I should take, things I should consider, things like that. So within the research area, figure out where you are right now within the lab. Like, are you just a contributor, a co-author, or first author kind of category? Definitely helps, I guess.
Yeah, that's a good way to put it. I think when I started working with my professor in my current lab, I wanted to make it clear to him that I felt ready to lead on my own project. And I was able to justify that I was ready because I had used my own personal time to, read some papers, develop some ideas, and even like make a presentation about it to him. And I first presented it to a PhD student in the group, and he was interested in it and said that we could pitch it to the professor. And it ended up being something that I presented to the whole lab a few weeks later at a group meeting. And I'm still working on that project right now. And that's the first author work that I'm doing. And I think you ideally can be in a lab where your professor does believe that you have that capability of being independent, especially if your plans are to go to grad school. Some advisors prefer that you are an independent problem solver who can also lead a project and collaborate with others. And yeah, there's lots of avenues to get into AI research. Topic-wise, as Stone was saying, there's a diverse problem set in each field. You could do it where you apply it to some engineering discipline. You can apply it to something more pure like math. And that's probably something that some of our other panelists can talk about better. But yeah, I'll leave it to them.
For me, so I'll sort of add like a fourth category to what someone was saying, and that's you can also be in projects where it's literally just you and the professor. Like there's no like super big team or anything. And it sort of depends on the lab / the advisor style. Some labs are very hierarchical, so it's like some other student in the lab is kind of like you're like the Padawan to this other student. Especially if the professor is newer, so maybe they don't have that many students yet, that might give you a bigger chance to actually work one-on-one with the professor. If it's like a huge established lab, then it's more likely it's probably going to be very hierarchical. So I've actually been in a situation where it was one-on-one. I've also been in a situation where it's like a group project. So both have their pros and cons. It's nice to get a feel for both. Check out which advising style you like if you can. But yeah, there's like multiple different ways you can work in different project settings.
So for me, I'll talk from two perspectives. I'll talk from outside because I actually kind of like double up my research. I actually still do like the nanoengineering research. So I have two projects right now. One is a project that's currently been in the works for like 3 or 4 years, but my nanoengineering side, and the other one, the more recent one, is the ML project. That one I'm also still currently working on. Both of them I'm working on. The first one I'm working on is the first order capacity, as Jason described. It's like you and the professor, and then the other one I'm actually working with someone else, and then we're working together with the professor. So just me, him, and the professor. And I think in general, the good part about being like, you and the professor is that you're forced to learn everything really quickly, if that makes sense. because otherwise you're not going to be very useful, because you can't rely on the PhD student to like fill in the gaps. If you don't know something, you have to fill in the gaps yourself. And so what I learned in research is also something along the lines of you get what you put in. So it's a bit like cooking. If you only spend like very little time, you don't really take care in like the kind of things you put in, you're not going to get much out of it. But if you're willing to put in the time, professors will notice and appreciate it. Usually it's something that they might not tell you up front, but like, even if you're not that great, initially, but they see you're putting in the effort, they're more willing to help you and advise you on it. And also usually you get better results in general, because like sometimes research is just like you're going to have to fail a few times, and it doesn't matter like how good you are. There's always some stuff that you're going to fail in, and like it's about powering it through and eventually getting to like the results that you want. And like in my case, it's like it's things like iterating quickly when your experiment's done, quickly iterate on the next experiment, figure out what went wrong, read the literature, figuring out new ideas to explore, discussing with the professor, triaging your time because you don't have a lot of time to just try everything. So all of these are like things you do in like AI research, and like in particular like a bit about my research topics, like we do a little bit of like image processing of microscope images, I think. And a lot of regression, a lot of things like that. And we do a lot of like hydrogels and 3D printing. So like there's a lot of things I'm doing in that aspect. And that's how I apply it to my domain. Apply machine learning into my domain. Like I do a lot of image processing on all these kind of experiments that I've been doing in the nanoengineering lab.
Okay, I'm going to try to be quick. So I had a more or less, and I guess sort of ongoing one-on-one research project with a professor in the MAE department. I think kind of to add on to give some caveat to what people have mentioned before, there is a major benefit to doing a one-on-one project, besides that you are having your own kind of creative output in this regard and the ability to drive a project, but also you actually get a more direct contact with the professor who is advising you. And so they're able to form an impression of you based specifically on your work, more so than just you as part of a group or a team. However, at the same time, I don't recommend necessarily just gunning for opportunities where you're going to be only your like a sole author, because I feel like, or I suspect it's quite valuable experience to see or participate in a group project, to see the process of making a paper from start to end. So actually seeing the whole kind of pipeline and process of how this happens, and that these kind of solo or one-on-one projects, they can be quite isolating, and you don't get necessarily the same level of experience of bouncing ideas with others, interacting with others, and a kind of framework of how you should orient yourself. So I would recommend kind of seeing, or if you want to start getting into research, try probably participating in like a group project or a project that's led by another student, just to see how the process actually occurs and folds out.
Yeah, that's actually really good advice. I needed to get experience seeing what other people did and how they navigated a research project from start to finish, especially like for how to publish a paper. I had no idea how that process worked until I saw it firsthand at an internship I did this past summer. And, definitely try to work with someone who is more experienced than you with that. It could be a PhD student or a master's student that you help out. You can maybe help out in some like second or third author or whatever, some type of secondary capacity, and you still got technical hands-on experience. And eventually in the future, when you want to maybe upgrade to that next level, you'll know how to do it a little bit better. So yeah, we spent a lot of time on that. Okay, maybe Joseph, you can talk about.
Okay, so for like AI courses, there's a lot of professors, at least for machine learning, they kind of expect you to at least have some background, and like the more background you have, the easier it is to jump in. Like I'm not saying you have to do all of them. I'm saying it's much faster if you do all of them. So very barest minimum Math 20C Math 18, these two are required because most of machine learning involves matrices and gradients. Probability and statistics, so Math 183, Math 188, that's good because a lot of machine learning also involves probability. So if like you have these, like these should be taken off like really early on in your first year. So by like end of your first year, you probably already have like some of those concepts. You have enough to work with basically, because anything less than that, and it's sort of like, there's not really much you can do. Then that's like if you just want to get in as quick as possible. If you want to like increase your chances even further, taking classes like 151B, like deep learning, 150B, which is probabilistic search and reasoning, and you know, the Cox machine learning series, 118AB, for example. Those are like direct, you actually implement machine learning models, you learn about machine learning. Those also have professors that, you know, would be interested in taking you in sometimes, or would know who's taking students in at the time. And there's also other like related machine learning courses that also like build your core competencies, like Math 173A and B, which actually like, you know, covers things like optimization in machine learning. And that's actually very useful because most of the math you see will be covered in that class. EC 175A is another one. Cox 108 is sort of like if you're on a budget, like class budget, and like you only have like one class you can take, then that will give you exposure to like a whole data science pipeline, a bit of machine learning. That will give you like general like understanding of like what machine learning is, and that also can give you some idea of like how you break in, like what kind of like machine learning topics you might want to like be working on, because it gives you like a big survey of like everything in data science. And yeah, there's more, but these is like a good place to get started course-wise.
And yeah, I think continuing on this path of how can you learn it, some of us are not fortunate to take classes in the CSE department or ECE, so there's a need for alternatives for how you can learn about deep learning. And in fact, I think self-learning, deep learning is, it almost makes more sense than learning it in a lecture, because if you're going to do AI research, much of what you do is, you know, you'll read papers on your own and understand the material on your own mostly, or just discuss it with someone in your lab. It could be your advisor or a grad student that you work with. But in terms of resources, this is just like a short list of things. This is definitely not the list. In fact, we're working on a resource list right now that we will be publishing very soon. It should be a pretty exhaustive list of like just about everything that you could find useful and that has helped us. These are just some of the resources. Just to name a few, like you could do an ACM AI quarterly project if you haven't already, and work with one of the board members on a project that you find interesting. You could do a personal project, make a nice GitHub repository, a Colab notebook or something, and that's something you can display not just on your GitHub, but your resume and to anyone that you want to work with on research in the future. Don't know how to get started? You could always do PyTorch or TensorFlow tutorials. So learn some sort of deep learning framework if you wanted to get right into coding. And you could even do what some folks have done, like you could do Kaggle, compete in a Kaggle competition, and there's tons of ways to get involved there. And yeah, I guess going to the next slide.
Really.
Oh, yeah, go
I wanted
ahead.
to add, if
Yeah.
you're interested in terms of like getting into reading papers and you're really struggling on this bottleneck of like you start reading this paper and you feel completely lost, I really recommend some of the some YouTube channels. So there is Yannick Kilcher, I believe. He has a lot of really nice videos where he breaks down a lot of more complex papers and idea and concepts that they're doing in a much simpler way that's a lot more intuitive. And it can also give you some kind of context of how you should be approaching and reading these papers. I think there's also like Henry AI Labs does a similar thing. And also for just general broad aspects of research directions and questions that are kind of within the research community. I believe there's Machine Learning Street Talk, which is like a podcast where they interview various ML researchers in different spaces.
There's also like I think 5-minute papers or something.
There's 2 minute,
Yeah,
2 minute
papers.
papers.
2 minute
2 minute
papers.
Close
papers.
enough.
That one is more just like showcasing cool results.
Yeah.
Yeah.
Than really going into methods.
Next slide, and then we'll get to Q&A. So where can you go with AI research? You could do all sorts of stuff. You could go into industry, work as like a machine learning or software engineer. You could get into that with just a bachelor's degree, or say you want to do research in industry, then maybe you'll want to have a master's degree or a PhD. You have a master's degree, you can likely be some sort of research engineer. Whereas if you are a PhD student, you can work on as a research scientist.
Yeah.
But
Also to add on
Yeah.
this, it's not necessary to get a master's, but
Yeah.
like you don't expect to be like applying for like machine learning engineer positions because usually that requires masters. But some software engineering teams, they can assign you to machine learning teams. Like in this case, in my case, I applied to Roblox as a software engineer, and they're placing me in they're giving me a choice of machine learning teams to choose. So effectively, I am working in machine learning at Roblox most likely. And also, I think I also heard like anecdotally, there are people who have gotten into like machine learning like rotation programs. Like there's one person that got into like Apple like AI ML machine learning rotation program as a cog sci major, if I'm not wrong. So she's she's doing good without like a master's. And it's all possible. But masters definitely does help it open the range of like direct ML positions if you're really interested in that.
Also, in terms of there's like this question of like industry versus prop, honestly, I think as an undergrad, kind of too young, too early to be worried about this. This is like, you can try TAing to see how your exposure, like how you like working with students and teaching and grading, but like, I don't think this is really a question that like undergrad should be worried about. Oh, what am I going to do in that work?
And also like it's important to understand like what ML engineering actually is. So for the most part, from what I've heard from people working at Microsoft, which is where I interned, you don't really like do research. It's more about like sort of maintaining the pipeline. Like there's a lot of data that's involved in machine learning, so kind of code that's based around that. It's a lot more of the engineering aspects rather than the research part.
Also, data science is a very similar and related stuff, and that like a lot of these terms will be used interchangeably. Don't just look for ML to be in the name. Data scientists oftentimes do the same things.
Also to add, ML engineering, and this holds true for like Roblox and pretty much every company. Most of the time, as an ML engineer, 80% of the time, you're actually just building the data pipeline. So you're just like databases, you're writing all the APIs and everything, ingesting the data. The actual making the ML and everything, which is like the bulk of what we do in these ML classes, that's like 20% of the work. So like that's to just give you all your time, trying all these cool architectures and things, trying all these cool style, if I'm not wrong.
Why is this kind of my AirPod?
maybe turn off the Bluetooth.
Just keep talking. Okay, sure, fine.
Okay.
But yeah, I was gonna mention we go next slide. But yeah, usually in industry, I think roles are really weird. Like I worked as a machine learning engineer intern, but I ended up doing like a little bit of research anyway. So you have to be careful what the company is offering. If they're asking for building data pipelines, then it'll be obvious. But always ask your recruiter if you're going to interview, like what exactly you're doing. But yeah, now we're going to Q&A. So if you have any questions, ask them now, I guess. Any burning questions?
We also
Or just,
have a
like,
prepared.
any concerns as well. So like if there are just whatever you feel like, oh, this is something that I'm decisive, I'm not sure about, sort of just voice your concern.
Okay, like open the Zoom chat just in case anyone's asking questions.
I don't think anyone asked anything in there.
Yeah. Also, if you're in Zoom and you have a question, feel free to ask.
Or are there like any terms that
Okay,
were
someone asked a question.
Someone asked.
How long does one I guess project take?
It completely depends. Like it really depends on what field you're in. Like Joseph has been spending a few years on his project, but I did a summer project that was about 6 months in total. It depends on the research field. Yeah, because it started in summer, like in June. I was done roughly by the end of November after we had finished writing our paper and submitting it to the conference. So maybe more like 5 months. But yeah, it totally depends on the field. You know, some research takes years, some research can just take half of a year. But I would say, like, on average, if you're doing something like NLP or computer vision or anything with reinforcement learning, like, you could get a pretty decent incremental project in about 6 months. But if you're trying to invent something like really new, then maybe a little bit longer than 6 months.
It also really depends on like how many people you're working with.
Oh yeah.
The more people you work with, the more people kind of driving the project, especially if they're very experienced, the faster. But typically faster than like 6 months is not that common. I think like I've heard just general guidelines are like 6 months to a year is like kind of recommended for a PhD student sort of deal.
Yeah, 6 months to a year is like the cadence for most machine learning projects, because like that should be the amount of time it takes for you to count the idea, like, you know, run the experiments, write the paper, and like proofread and all of that.
Is there like a certain time of the year that's best to like approach professors for like open slots, or is it like any time of year? Like, is it like fall quarter more open positions, or?
I feel like January is a great time because, at least for the purposes of like the relevant AI conferences, there's kind of a slowdown in January. In early January, though, it gets a little bit busier towards the end of January and February, and then a little bit more open again in like March, April. So I'd say early January, and also anytime between March through, I'd say, the end of April. Yeah.
Is that the context of like how busy they are at the time, or just like openings? I think opening wise, I don't think it's really gonna matter.
Yeah,
Apply is kind of as soon as possible.
If
probably.
they want you, they'll make time for you. And also it's also in terms of like, even if they are not available at the time, contacting them, making sure you are lodged in their mind, and you come down later the line and like, hey, by the way, do you still have, are you sure you haven't, like, do you have any positions now? Usually then you'd be like first to like be offered the position, rather than, you know, someone who asks like later. So it can't hurt to just ask when you're ready, when you feel you're ready to do research.
Yeah, I also had like I think like the only main time constraint really is if you're in a research program and you need to find a mentor by a certain date. So for example, I was in one of the undergraduate research programs here at UCSD, and they required a mentor by like before January. So like in December, I was like frantically trying to find a professor. But ideally, yeah, you know, in that case, I would have tried, you know, maybe earlier in the fall.
Yeah, there's not like, yeah, you can technically apply whenever, but sometimes if your professor is not responding, it might be worth looking into papers that they've submitted to like certain conferences and see if those acronyms for the conferences are accepting papers soon. Because usually there's like a big research paper grind right before where they probably won't respond to too many emails. Hello. And we have another question. This is from Zoom. So, question from Shubham: is there something you do not like about doing AI research? And is there a reason one should not go into it?
Oh, I think I can talk about research in general, and that is that that's how I put in like classes. Like that is an incentive to do your homework, because if you don't do your homework, you know, you're gonna like flunk the class. In research, everything you're gonna do is motivated by you. Like there's nothing like if you don't like read your paper, there's no one that's gonna like give you a bad grade. You just the research just stops, if that makes sense. So it's like all of this has to be like self-motivated. And sometimes, like, you know, while you know, sometimes you're very gung-ho, it's sort of like an attrition thing. If there's nothing more than just, you know, like an initial like like burst of like enthusiasm holding you together. Like if there's no like real passion or like anything beyond that holding you together, then it's like you'll sort of be like you sort of like burn out quite quickly in a sense. And because like you have to keep being interested in a topic and keep wanting to learn more in order to like keep going in research. And like if you're unable to find that, or if like it's not sufficiently interesting, like whatever you're doing is not sufficiently interesting for you to like maintain that level of like enthusiasm, like you'll burn out and you'll kind of hate it because like it's a slog otherwise, because you're reading papers. These papers are very technical. The payoff of like reading that paper, like no one cares apart from you and like and what you can get out of that paper, so I would say like that's in terms of like why you wouldn't want to go into research in that case, and what you have to think about, because
I want to give a quick clarifying though. Don't expect that like you're gonna have this passion from the get-go, or like even before you've started a research project. The passion isn't gonna be like great strong enthusiasm like right there from the start. It's something that you kind of have to develop as you work through it. So you want to have a curiosity, you want to have a problem that you're interested in and you would like to solve, but don't expect to have this just overwhelming like desire that you need to get this done and like just from the start. And it's something that kind of comes around and comes about as you work toward like this goal, basically.
Yeah, I'll just add that like there's a lot of failure that happens in research. So sometimes you could be working on some things for very large time scales, and then at the end of it, something goes wrong, and you kind of have to be okay with that. And also like you also have to be okay with things being very unstructured at times. So again, it kind of goes back to the industry versus software engineering versus research, where you have to be okay with things not being so straightforward. It's not like someone's handing you, oh, here's a design, just implement it, right? That might be true in your classes, like you get a PA write-up, right? But in research, there's no PA write-up, right? Like you're the one that's producing the PA write-up, so you have to be okay with like that lack of direction at times.
So Nahal has a question about, could you expand on the robotics related research? Is it in computer vision? What focuses was that research on? So I can talk a little bit. I do some of this, although not on the physical robotics, but more on the simulation side. Robotics is also a pretty big field. Generally concerns taking, the end goal is taking a robot in a physical space and make it do something that you want it to do, right? Like pick up a water bottle and dump it out, or open a door or something. But to achieve that goal, you need to equip a robot with capabilities to understand the world. One of the main capabilities is vision, right? We as humans, you can think of ourselves as robots, but we have eyes that process the world and give us signals about what to do. So like if we see a red light, we hit the brakes on a car. If we see a green light, we hit the gas, right? We use computer vision heavily to make sense of the world, and in a more mathematical way, we take a giant image, or RGBD, which is image plus depth information, which creates a point cloud, downsample that, process it into like a feature vector in a latent space. This is more mathematical now, but once you get a feature out of a camera's recording of the world, you then do something with it, right? You can make a classification, you can make it do a regression kind of problem, like say, based on what I'm looking at, I don't know, how hot is it or something, I don't know, or how far away are these objects, or where are the objects in the scene? And that information is then fed into controllers that use this information, use these generated features from your other models to make decisions about what to do with the robot. Like, let's say I look at this image and I can see a door, 2 tables, and that, and let's say the task was to clean up the room or something. Because I know where the tables are using computer vision, I can now do the task much more easily. So that'd be an example of how computer vision would be involved. I wouldn't say robotics exactly within computer vision, but they have intersections there. So if that answers the question.
Any other questions?
So John, you mentioned that for your current PI, you had to email them like 3 times before they responded.
Yeah.
So where do you draw the distinction between being persistent and being annoying? Because to me, like I would think that emailing 3 times would just end up being annoying to the professor, and they'd be less likely to respond. and so like I wouldn't press that much. Where do you draw that?
I think it depends on your scenario. I knew I knew what I had to offer. I knew I wanted to work with the professor. I knew I had a good resume. I knew I worked really hard, and I don't know. I just made it clear to him that I was doing an internship at USC last summer and I mentioned in my email that I was doing that I'm working in a big project and making a big contribution, submitting it to a pretty prestigious conference most would consider, and like I don't know, I just felt like not just that, but more importantly, my research interests aligned with it. What I wanted to work on with him. He hadn't done it before, but I had a good feeling that he would be interested in it. So pitching a good idea, having a good resume, and having a good purpose. Sometimes professors really are just busy. I emailed him once in like June, but maybe it was like July. He was at like this big computer vision conference though. And I followed up with him saying, hey, I went to your workshop and saw you talk. And I like didn't get a response, probably because he was busy. Then I waited about 2 months and it was about early September. I emailed him the first week of September, didn't get a reply. Then about 2 weeks later, I sent my last one. And then like a day later, I got a response. And apparently he had just had a baby. So he was actually like properly busy, but he said he had seen my emails. He was just himself really busy. So sometimes you really just don't know. And I think given the nature of like this all being a cold email, they don't know how I look technically in real life. So I had no shame. It's not like I'm walking past them every single day. So you have to be a little shameless about it and just, if you do feel like there's a good alignment, you have a good reason to be messaging them and you're not embarrassing yourself, then what's there to lose, That's how I view it. And it worked out for me.
Yeah, I would just say like personally, 3 is the max. Like
Yeah, 3 is the max though.
just send
Yeah,
the
no.
initial email and then like 2 follow-ups and then like that's it, move on. And also space out the emails. So it's not like you're saying day 1, day 2, day 3. Like that's just really annoying. So like, I would say like at least a couple of days or even a week maybe before sending the next email.
Yeah, honestly, like now that I think about it, the first email that I sent wasn't even like, I wasn't asking him if I could join his lab. I was just like trying to talk with him about his research. So it was more so the second and third emails where I specifically like attached my resume and stuff. So yeah, I was trying to see if you could spark a conversation with the professor over email about their work, but he was too busy. So that was a method that I tried and it didn't work. Yeah, any other questions? Yeah.
Do you know professors mind if you go to their like office hours, but you're not in their class or something?
No.
Oh, I can comment on that because I crashed like so many office hours. And they're perfectly fine with that as long as like they know other students asking questions, just go chat them up. Because that's why I crashed Gary's class, like Gary Cottrell, like his office hours, and yeah, okay, I basically crashed his office hours, and like that's the reason why he offered me like to take his 251B, and like he even I think he even like offered me like after the class like that position afterwards, but I was busy anyway. So anyways, like yeah, just crash. And I think what helps is that if you can impress one professor and then use that one professor to ask other professors, because that's why I started with Taylor. And Taylor was like,
Taylor Kirkpatrick.
Yeah, Taylor Kirkpatrick, and he was like, you're interested in this? Okay, go ask this professor, say that I sent you, and like that's what I did, and that's what I've been doing. That's my strategy right now for professors. Get buy-in from one professor, name drop him, and then usually the professor like, like it's easier. It sort of greases the wheel because it's like it's like a known quantity. Professors are more willing to work with you if you're like a bit of known quantity. Yeah.
And also just so Kirkpatrick and other professors as well. There's like UGCOM, I think undergraduate.
Yeah, UGCOM.
Whatever.
The
You can just join.
undergraduate.
Like their office hours are basically public for anyone to join.
Yeah.
Besides that, generally, professors, like it depends entirely on if there are students from the class asking questions. If there are, they'll want to deal with them first. But if there's kind of no one there and their office hours are pretty much empty, then like they don't care who's asking questions. They'll talk with anything. Keep in mind, by the way, professors are like people. Don't treat them or like view them as some pedestal, like some legendary creature or whatever that you can't talk to. They're very friendly people for the most part. They're very casual. They like to talk about research. They like to talk about life. And for the most part, I think they're out to like help you. They want you to kind of do well. They want to be nice.
Some professors can be a little scarier to talk to, and sometimes because their time is so precious, you might want to have a little bit of content prepared to talk with them about. So keep that in mind too. 'Cause I think for professors who might be a little bit more famous in their field, you can maybe verify that by looking on Google Scholar or something and see how many citations they have. But I think that oftentimes there's like a correlation between the higher the citation number, the harder it is to get their attention and impress them. So bear that in mind. And yeah, any other questions?
I have like another one.
Yeah,
This
sure.
is, like, kind of personally, I don't feel. I know you talk about like not having like kind of a passion like right from the start.
Yeah.
But I just like I don't really feel like I've like read a paper and then like, had interest, like had a particular interest for the topic, or like some like particular interest in like class content or something. But I'm like open to try it. It's just I don't want to like have like this like initial interest, jump in and like realize I don't actually like it, and I'm like stuck there for like 6 months or whatever.
Yeah, I was definitely in your shoes many times. Like I started off doing bioinformatics research because I was like, oh, I want to work on problem solving cancer. And then I ended up realizing it was like way too focused on biology and not really my thing. And then I ended up doing like the ERSP program, doing computer vision. But then the application of computer vision wasn't like quite my speed. I wasn't really enjoying it. And then I ended up joining a surgical robotics lab. And I was still in the other two, and I didn't know how to leave. So I ended up just not taking too many classes, focusing a lot on my research. I don't recommend this. Don't do this. I was in the surgical robotics lab for the longest, besides the bioinformatics lab. The ERSP thing I did like within the year that I did it, but I made sure that I was contributing enough time to each lab. And I think this is the least efficient way to do it, but I learned from the experience that I liked the robotic stuff. I liked the idea of having robots learn on their own, and I liked the computer vision side of things. So another way to do it that's maybe not as wasteful of your time is like maybe just do personal projects and look at different ways that you can learn about AI. You could do a deep neural network for, I don't know, predicting the cost of a house, or I don't know, just any task really. You could do Kaggle, see what topics generally sound interesting to you, and that could be a good indicator of something that you can do. And yeah, I think also David was saying you might not enter AI research being like super passionate about it. You might not know how to read a paper or how to understand papers in that field, but when I did ERSP, like we had this CS research class where they taught us how to read a paper, and from what I got out of it, honestly, when you start reading out papers, they can be pretty confusing. You only get better at reading papers by reading papers, though. You could read the abstract, and you can see the pictures and the figures, see what the contribution is, or try to understand it maybe, and you can go from there. As for like the more detailed stuff like math and the symbols and whatever, that's something that you'll understand more with practice and by diving deeper into the subject, assuming that you might like it and you're willing to learn it. But I think some of the other panelists have a better advice there too.
I can just add, if you don't like research, you're welcome to leave. It's a volunteer a volunteer thing. There's no one like caging you in, like, oh, we got you,
It's not like a class as well.
It's
where
not like a
Yeah.
class like where like you can't just drop the class, you get a W, it looks really ugly, or like you get an F. It's not like that. You just if you really don't like it, just in my opinion, just drop it. Like like do it like professionally, like tell them, give them notice, like, and usually at least for what when I worked in the lab, when I first joined the lab, the professor did give me a nod. She like after 3 months, she was like, "Do you still want to work in my lab? Like, if you want to change your mind, this is the time to change your mind. If you like what you're doing right now." And yeah.
Oh, I have a question.
Yeah.
But continue.
Yeah.
Oh, okay. No, so like, no, so basically, like professors understand because it's not like you're not like in the PhD right now. In fact, this is the best time to like get into research because it's a lot easier to back out now than when you're in the middle of your PhD. It's because by the time you're in the middle of PhD, you've sunk a lot more resources, you've sunk a lot more time. It's not as trivial to like back out. You can't just dip out next week. If you're in a PhD, it gets complicated then. So if you want to find out research right for you, it's best to do it like while you're in undergrad.
I would just add,
Have you guys like dipped out of any research? Just curious.
I definitely have. So I started off doing some front end for a lab. I built a bunch of websites and a bunch of interfaces, and I built on the back end. And then gradually I shifted to research. This lab was in a design lab. So the research I was initially assigned to kind of work with was very HCI focused. It was actually HCI and ML. I was looking into it for about a few months, and then it kind of just teetered out because the other PhD student I was working with ended up moving labs actually, and then kind of just like lost contact. And I also wasn't very interested, so I kind of put like less and less time over months, which wasn't good. I should like just cut off immediately. But yeah, I definitely had like a failed project effectively, didn't go anywhere in the end. Ultimately, I just said, okay, I want to change projects. So I didn't leave the lab, but I told the professor like I wanted to change projects to focus more on the machine learning side, of which I did, and now I'm still working on. So yeah, I mean, so it's very common to happen. And the other thing is like you don't need to be afraid about anyone like bad mouthing you or anything. It's not like all the professors like talk to each other like, oh, this student is blacklisted. Don't talk to them. That might happen between student orgs actually, but between professors, definitely not. There is no sense that if you quit one lab, it means you're blacklisted from all other ones. It's definitely not the case.
Yeah.
Professors don't have that much time to be gossiping about every single student.
They cannot care about you anymore.
Yeah.
Judy.
So I guess how do you manage your time when you're doing research? Do you like focus on research in one day, or do you like space out over time? And how do you just get into it and actually do something and work on it?
Can talk about this a little bit. So
Wait, could you repeat the question?
Oh, so Judy asked a question. She asked a question about how do you manage your time when you're doing research with like schoolwork and whatever. I can comment a little bit. I do the really bad thing where I don't go to half my classes. So don't do that. But before, when I didn't go to classes, like back when things were in person, I typically had like a good chunk of the day, just like one day I'd actually like just look into research stuff for most of the day. And then the other days I do my homework instead. And this worked out really easily because I tend to do all my homework on Fridays. So the rest of the days I can just do research stuff. I think another big proponent is, in addition to doing research, you actually need to have some level of skill. If you're a student who consistently struggles in class and needs to spend more time doing classwork to get a degree, research might be difficult because you're spending all your time doing classes. If you're a student who can easily do all the classes, research is a great option because you can just ignore your classes and you still get an A or something. I don't know. So I'd be closer to that side. I've taken a lot of really hard courses in the first year to prepare me for now. In particular, I took the honor series for math, ended up doing really well, and now all the math courses are like a breeze now. But it's really a good idea to be aware that in order to help manage your time, you got to prepare for it. So if you're thinking about research or any possibility, make sure you prepare well. So take the relevant courses or do the relevant self-learning. Make your future classes really easy, if that's possible. So that's one avenue which I try to pursue. And the second thing is just like having a day just to focus on research. Like I'm a person who is really bad at context switching. I can't work on like 3 things at once. I do slowly and all, so I tend to do that. But different people have different preferences, so you do need also to try it. So maybe like spend 1 week trying one format and another week trying another format, see how it turns out.
Yeah, I think it totally depends on your work style. It's like your question's almost similar to a question I remember asking like CSE advisors when I first transferred here. I was like, "Hi, I'm new to UCSD. How many classes is too many classes? I was on a semester system before. What the heck is this quarter system? What does that even mean? Like 12 units? How many hours is that?" But some people can handle like 5 or 6 classes like a breeze. Others can maybe just do 3. I'm of the latter where I can probably do about 3 classes and research and still be productive in both settings. It totally depends on you and your work style and all the commitments you have. I think all of us here who have done research, we're generally involved in ACMAI too. And yeah, I think you probably will need to experiment like with different strategies. Sometimes what I do is like, I notice that I have certain free time on certain days. I'll maybe reserve a few hours here and there to just sit down, put my headphones in, and just kind of like read a few papers or get some code written. It really does depend on what's on my to-do list. But that's one strategy that I do now. Just look for any gaps in my schedule, make time, of course, to like go out and enjoy life. Don't sit inside all the time working on research till like 5 a.m. But yeah, I've also been in that position where like I've worked on research for too many hours and I'm up late at night. It does depend on like the urgency. So yeah.
Yeah, I would just say like view it as another class. So when I was scheduling like my research for my other classes, I just considered it as like another hard class that I was taking. And then, I just kind of proportioned that into, the workloads that I can handle usually.
But yeah, you can also get credit for like research. Like right now I'm doing the CSE 189H in my second quarter of it. And that's the CSE honors thesis. So you'd probably want to communicate with your advisor about that if you want to do a thesis and what the topic would be about. But that's like you get research units and also it counts for a letter grade. So it can boost your GPA very easily. You can also do like CSE 198, which is direct group study. If you do a program like the CSE ERSP program, then you would take 2 units in winter quarter and 2 units in spring quarter. The expectation is that each unit is, I think, 4 hours of work. So with 2 units each quarter, you're expected to roughly work on research for about 8 hours. So maybe when you're getting started in research, maybe aim for 6 to 8 hours each week. See how that feels, and then if you notice that you have a lot more time and a lot more interest, maybe boost it up by like an hour or 2 until you've kind of reached that capacity.
So I'll like comment on like how I do it. I don't usually look at the time. I'm usually more of a results oriented kind of guy. So like if my next lab meeting is in like 5 days, I usually aim to have something done and that I can tell my professor I did in 5 days. I feel like that's how I do it. So like it's sort of like it organically works itself into my schedule. So like it's like just treating it like another homework assignment, I guess. That's how I usually plan it. And that works because like then in that case, you're not really sweating about the time, you're just sweating whether you did it or not. And sometimes it's better. For some people, at least for me, it works better that way for me, because then that way, like if you don't, if it took like 3 hours, you still feel like you did something. If it took you like 12 hours, you still did the thing. And like I mean, like it's not necessarily like the healthiest way, because sometimes, at least for nano, like I'd be in the lab until like 2 a.m., which is not good. But anyways, like that's like another like way you can approach it. Another way you can think about it is that the more time you spend on research, the more you're gonna get out of it too. So it's not like you need 3 hours a week or something, or 8 hours a week of research. It's like if you double that time, you get more out of it, because like you have more time to do experiments, you have more experience, you learn more things. So if you think of it in terms of like, I just need to get this done, and like it takes a fixed amount of time. It doesn't really matter like if you did like 2 hours a week over like a longer period, or you did it like most of it like in a week over like a very short period. Like it's still the same product, or at least like a similar product. Yeah.
I think last piece of general advice, and we'll probably wrap up after this. So like Jason is going to go to UIUC for his PhD, and David's going to go to University of Toronto for his master's. And you might be wondering like, why would I apply directly to a PhD out of bachelor's, or why would I directly apply to master's? So maybe Jason and David can talk briefly about it.
Yeah, I mean, like, I guess like it's whether or not you feel like you want to do research. Like if you're kind of on the fence or you don't have any experience, then you can try for master's and get a little bit more time to figure it out. But if you know, like for sure, like yeah, I want to do a research career, just go into PhD.
Yeah, so for me personally, I applied for both master's and PhD programs. I think there is a sort of balance or a question of PhD typically would be sort of more focused, as in like you've already got a pretty concrete idea of what exactly you want to work on. You've already had experience working on that or something quite adjacent. And so it's more of like a continuation, and it's more clear cut. Masters gives you opportunity to basically reevaluate. Also, there's a huge difference in types of master's programs. A lot of them, for example, are very course oriented and are just basically preparing you for industry, whereas other ones are going to be a lot more research oriented, like for example, the one at Toronto. And so it's more of like an opportunity to kind of reevaluate what it is that you want to do within this space. So like what research do you want to pursue? And I think part of it as well, like for PhD applications, they can be quite competitive. And so it'll quite a bit depend on how much research background you've already had during your undergrad, especially within CSML. And so master's programs are also kind of this opportunity where you can kind of catch up to whatever research that you've been kind of lacking. Like if you don't have really any publications, this gives you an opportunity to sort of make up for that.
All right. I think that concludes our Navigating AI Research presentation. Thanks for joining us. Yeah.
Let us know in the Discord if you have any more questions. So
Yeah, feel free to stay if you have more questions. And, yeah.